Yeah, how to
No,
banabo?
sir.
You don't
No,
remember
sir.
that? No. Okay, then after this class, okay, probably you have some friend in many private universities, even some other universities. Okay, you try to ask them whether they have heard this term earlier than you, or even they did not know about it. But I think they heard about it. The reason is that in my assessment, okay, those students are, they, as they think themselves that they are in a private university and their existence will be very competitive in future. For this reason, they try to engage themselves to the extent of their ability so that they can be a true competitor for others, those who are, they would say, superior than them. But you guys are so complacent that when you entered IIT, then you say you feel that your IIT is, this IIT is enough for you to become an engineer and to go into the competition, that where there is no any difference between any institutions, among any institutions. Okay, no matter from where you are graduating, people will never ask you. Rather, they will ask you what you know about that profession, what can you do. Do you believe this?
Yes, sir.
Yes, sir. Yes, sir.
If you believe this, then can you imagine that how many competitors you will have after your graduation? Do you have any idea in this country how many electrical engineers are being graduated per year? If I were you, I would never choose electrical engineering in this, for example, age to become a professional something. The reason is that we have our engineers flooding over the country. Okay, everyone wants to become an electrical engineer in 110 public private universities, in 30 or 40 government universities. All those universities have triple E department. I don't know whether this country needs that many electrical engineers or not. For this reason, what will happen after your engineering graduation? I don't know how many of you will be able to go further for higher education, and but will remain there, and your private sector is not also developed. They will need very competitive engineers. They will give the salary of 3% to a one engineer, and they will extract output of 4% from him. And only few of them will be competitive to get those such jobs. Otherwise, the other will, what will happen then? So be careful about that. The competition is anonymous type. Okay, it will not, for example, be defined by from which university you have graduated. Be careful about that. So this accreditation board is now become a very important issue for engineering education in particular of this country. If your program will not be accredited, then as a professional engineers, your mobility will be restricted, and eventually after a few years, your degree will not be recognized as as an engineering degree that is professional. Okay, in order to do that, your engagement in your education should be such that you can solve some problem that will benefit the humankind. Otherwise, engineering has no value. So Abbott defines engineering in this way. Engineering is the profession in which a knowledge of the mathematical and natural sciences gained by the study, experience, and practice is applied with judgment to develop ways to utilize economically the materials and forces of nature for the benefit of mankind. Can you understand what is your role and what equipment you need to do that? You understand what mathematics, what is the role of mathematics? Hey, can you do that without mathematics?
No, sir.
No, sir.
No, sir.
What do you mean by natural sciences?
Physics, chemistry, biology.
Physics, chemistry, biology, etc. Okay, very fine. So those things are also needed. That means in order to utilize the materials and forces of the nature economically, for the benefit of mankind, actually your understanding lies on mathematics, your understanding lies on natural sciences, okay? Nothing less, nothing more. For this reason, you have to start with those things from the very beginning. Mathematics is very important for us. The reason is that mathematics is our language. Unless you know the language, you cannot speak. So if you do not know your mathematics, then your engineering cannot be learned. Not only engineering, anything that is similar to engineering or that has some relationship to do something for the benefit of mankind needs mathematics. So if you do need mathematics, then what will happen? You have to know that the mathematics is what mathematics you need, because you are not a mathematician. That means we need such mathematics that will help us adequately in solving our engineering problem. Then what will be the hierarchy of the engineering problem? Okay, look at this slide. I prepared this slide when I used to teach first year electrical circuit course. This is the first thing I usually show to my student. Actually, the thing is that if we have a physical system, for example, you may have a mobile phone, you may have an other electrical gadget, or you may have an electrical motor, you may have an electrical heater, you may have an amplifier, something like this. Lots of electrical things are there around us, we are using constantly. Then if we bring that electrical system to the blackboard and show it to you, the photograph, uh, uh, something like this, will you understand anything about it?
No, sir.
Then what you need to do? First, you have to know that what is inside this thing, the operation of this device. Once you know the operation of this device, then what you can do, that physical system can be translated into an electrical circuit like something by using some standard schematic. That we can use the symbols that we usually use to represent the electrical active element. We can use the symbols to represent the electrical passive elements. We can use the symbols to represent the electrical sources. Electrical sources can be of independent type or can be of dependent type, whatever it may be. And if you know the topologies, that means how those elements are interconnected to give you a desired output, all these things can be put into the form of a schematic. We call them electrical circuit or electronic circuit or electromechanical circuit, in whatever you can call them. So once that electrical circuit is available to you or electrical system schematic is available to you, next thing is what? Next thing is you have to identify what are the physical quantities associated with it. What are those physical quantities? It can be the voltage, it can be current or charge or something like this. If those elementary physical quantities are available to us, then by using those quantities, we can calculate the other quantities like energy, like power, like efficiency, or whatever it may be. So next thing is what? After having your electrical circuit drawn, you have to associate the physical quantities with that electrical circuit. Next thing is what then? You have to apply, you have to find the relationship among them. So if you want to find the relationship among the physical quantities involved in the circuit elements, then you have to take help of some natural laws. Those laws are what? If you want to use element-wise, then you need to know Ohm's law. And if you want to write a branch-wise something, you need your Kirchhoff's voltage law. Even if you are going to a junction, you need to use Kirchhoff's current law. If you have a loop, you have to use your loop analysis or node analysis or a combination of them. Just this thing will give you a relationship among the circuit elements with the physical quantities involved. That will give you a series of equations. Those equations can have, for example, this is some fictitious something, but it will give you this type of equation, something like this. Those equations can, in general, of simultaneous type. They can be algebraic form, or they can be in the real form. They can be in the complex form. or they can involve derivative. When derivatives are involved in this equation, we call them differential equation. So in your mathematical courses, you have learned how to solve simultaneous equations. You learned how to integrate, how to differentiate, and you know how to solve differential equation. You have your differential equation two type. One is called ordinary differential equation. Another is, what is the other type? Partial differential equation. Very good. So those are the mathematical equation in general. How we are actually obtaining them? We are obtaining them from our physical system by using a mathematical or a modeling hierarchy. Once we arrived in the mathematical model, it can be algebraic, it can be differential or integral differential, whatever it may be. Then from this point ahead, what thing we need actually to go ahead? From this point ahead, do you need engineering? Hey, from this point up, for example, do you need engineering?
No, sir.
Yeah.
Math.
For
We
example,
need
if you
math.
go from that point upward, do you need engineering or not?
Yes, sir.
Yes, sir.
Because this is how you know the engineering, and from that engineering you model your system and you obtain some mathematical set of equations. So from this point ahead, what do you need to know? You need to know the mathematical technique, isn't it? To solve them.
Yes, sir.
Yes,
So
sir.
you can solve
Yes,
them
sir.
by using analytical method. You can solve them by numerical method. Now yet you do not know what is numerical method, okay? I will try to show you. The reason is that whenever an analytical method is available, we can solve the equations in a closed form by using the standard technique that we have learned in our mathematics. But in many cases, when analytical method is not available, then what you need to do, later we will show that almost all the analytical technique can be converted into some approximated form. Those approximated form will involve only addition, subtraction, division, multiplication, or some logical operations. Okay. And when these operations actually, that means your analytical technique is converted or transformed into some other form where your integration, say, or your differentiation or your partial differential equation or whatever method you have learned can be transferred into a form of addition, subtraction, multiplication, or we can use some logical operation there. Actually, these are the things that a computer usually do. You know that computer has a unit, we call it ALU. Do you know what is ALU? Arithmetic logic unit. That means this is the unit where all the computations of your computer is done. That means your computer can perform only your arithmetic or some logical operations, nothing more, nothing less. If your computer can do these two things only, then another perspective of numerical technique is what? If we have our electrical engineering problem or any engineering problem that are very tedious and huge in nature, sometimes the analytical technique or by using hand calculator or other technique may not be possible, then we can take help of our electronic computer to solve this thing. So if you want to use our electronic computer to do that, then you see that your computer can only perform arithmetic and logic operations, nothing more than that. Then your first step would be what then? The method that we are using should be converted into a form that will involve only addition, subtraction, division, multiplication, or there can be some logical operation in it, depending on the type of the problem. So actually the numerical method that we are going to learn is not mathematics. It is the method, like your other method that you have learned earlier, that will not what you call hamper the basic principle, but it is an alternative form by which you can make your computation or calculation easier, and you can deploy, for example, computer efficiently to have a solution. This is one perspective of numerical method. Another perspective is in reality, only a very less number of problem will have analytical solution, because analytical solution is generally obtained for a system that is called linear. Do you have the idea about linearity of a system? এটা কি হলো, এটা কি উত্তর হলো একটা প্রশ্নের যে what is linear when the input output is linear? Is it the answer of a question? You learn the thing in your electrical circuit in this way. Probably electrical circuit you have learned it when you are introduced with Thevenin-Norton theorem or something like this. Okay. What are the two conditions that are to be satisfied to become a system linear? One property is called a scaling property. Sometimes called homogeneity property. Second property is called superposition or additivity property. It is called additivity, and this is homogeneity. Okay, what do you mean by a scaling property and superposition? If we have a system, for example, and you may have an input, says, let us consider that this is a single input and single output system, seesaw, and we are giving an input xt there, you are getting an output yt. A scaling property says that if we scale the input by a factor a, your output will also be scaled by the same factor. Is it not something like that? The relationship will be y is equal to mx type nature. If this is your independent variable x, the input, this is your output dependent variable, then it will be a straight line, something like this, isn't it? You can say that your input output is proportional to the input, isn't it?
Yes, sir.
Okay, now I have an equation. This is also a straight line. For example, something like this. This is your x, this is your y. And the equation is, say, it can have the same slope, y equal to mx plus c. Okay, you have, say, figure 1. You have figure 2. Are both linear? Justify. রোজা থেকে বেশি কথা বলা যাবে না, গলা শুকিয়ে গেছে, বুঝছো? 1 ঘন্টা করে ক্লাস নেব রোজার মাসে, just 1 hour duration. Okay, justify that both systems are linear. With the help of additivity, homogeneity property. Because we have a single input and single output, only one property will be applicable there, that is a scaling property or homogeneity. Tell me. It's a very common sense, okay? A simple elementary level student can answer this question. If we have y is equal to, say, mx, and if we double our x, then what will happen? Your y, said 1 would be equal to, say, m into twice x. We are doubling our input. And that is equal to, is it not equal to twice y?
Yes, sir.
Yes, sir.
Then if we have our y equal to say mx plus c, we are doubling our input, then your y1 for the new input equal to m into twice x plus c. Is it equal to twice y?
No, sir.
No, sir.
এই জোরে বলো, গলাটা উঁচু করে বলো একটু, okay? Say loudly whether it is equal to twice y or not.
No,
No,
sir.
sir.
No, sir.
If it is not twice y, then is the this property is violated or not violated?
Violated.
Violated.
So is it linear?
No, sir.
Sir.
Non-linear. Okay, linear doesn't mean that it is a straight line. Be careful about that. Okay, that a straight line must have the property that a proportional behavior should exist. Otherwise, it can be linear in very restrictive sense, what we call segmentally linear or linear piecewise linear or something like this. This is what one property of linearity. Okay, this is very important. If your system almost none of our system will have this type of behavior in practice if you have a physical system, even in your Ohm's law. If we want to plot the Ohm's law, say this is your V and this is your I, and this is your slope. Okay, your slope of the line equal to what?
I by V.
I by V equal to what?
1 by
Sir,
R.
resistance. 1 by R. 1 by R.
1 by R equal to what?
Conductor.
কারবার জিজ্ঞাসা করা হয় একটা ক্লাস 9 এর প্রশ্ন জিজ্ঞাসা করলে, this is your conductance. Okay, now tell me, this is very ideal case. In practice, is it true? Why not? I do not want to go to that complicated something. I want to go to a very simple something that is understandable. Consider that your R will be the function of temperature, isn't it? Now tell me how in an electrical laboratory you are performing, you have given an R and a voltage source, and you need to measure the current by varying the voltage across flowing through the resistor. Okay, how your resistor will depend on temperature, because the room temperature is 37 degrees centigrade, say. How your resistance become dependent on temperature? Okay, find the answer in the next class. I will. Yeah, of course. Yes. Yes, very good. So that means we will have an I square R law power, and that power will actually generate heat, and that we know that the resistance of a conductor is equal to, very simply, this is very restrictive equation, 1 plus say alpha into del T, something like this, isn't it? Where alpha is the temperature coefficient of the resistance. Per degree Celsius, this amount of resistance will increase. That means the resistance will increase. If your resistance will increase, then what will happen? Your conductance will decrease. So as a result, what will happen? The slope of the curve will decrease. If your slope of the curve will decrease, then your slope will be coming, for example, what your curve will be actually not a straight line, rather it will be gradually decreasing, something like this, isn't it? But we have some material where this temperature coefficient of resistance can be negative. Can you tell me some example of the element where your temperature coefficient alpha is negative?
Superconductors.
This is taught in the first year electrical circuit course. And a nice description is there. In which book you followed in your first year?
Adiku.
Sadiku. We have many other books. Didn't your teacher reference something there? Only one book? George book and no other book? Boylested or what do you call Irving's book? Followed, okay, fine. So you can have a look of this book, okay, just to refresh your understanding. Okay, you will see that how temperature varies with resistance, and even some interesting things are there. Because if I want to go into it, then I have to again teach you very elementary things of electrical circuit that we don't have that much time. So you have to do there, okay? Many things are there. You can perform some experiment by yourself. For example, if you are given a lamp, incandescent lamp, okay, say 100 watt to 100 volt, then you can measure the resistance of that lamp when it was not connected, it is not connected to a source. Then you connect the bulb to a source and let it light for 10 minutes, then again bring it back and measure the resistance, okay? If you have your, how many of you have an ohm meter at your home? Multimeter, okay, no problem. If you have a multimeter, then can you manage a 100 watt lamp or to do that experiment? Okay, try to do it, but be careful about the heat, okay? Because 100 watt, it will be on for 10 minutes, it will be heated. So while you dismantling heat, be careful about that. Then you measure these two resistance and let me know it. Then some interesting thing based on your observation, I will discuss in some future classes. Okay, this is one property. Although many of the engineers, even the graduated, many doctors, they could not answer this question because they never performed this experiment ever in their life. Okay. So the second property is what? Second property is superposition. You know that superposition property will be effective only when you will have two sources there, say two or more sources, say x2. Then what will happen? Your yt will have the contribution from both the sources. X1 will also contribute to it, and your x2 will also contribute to it. If ax1 is the output ay1, say, and if we put say bx2 there, its output is say b into y2t, then your total output yt will be equal to a y1t plus b into y2t. Okay, that means your output yt will be the function of x and y. This is only possible when another property of your system is there. That property is called bilateral property. Bilateral property means if you have an element, that element is carrying current in this direction. Whenever you reverse the direction of your current, then what will happen? The property of your circuit will never change. That property is called bidirectional property. But if you have a diode, for example, in this circuit, if you allow current to flow through it, but it will never allow to flow current in the reverse direction. In these cases, this superposition theorem may not work. So that is what the conditions that you need to know before proceeding with linearity. So this superposition theorem principle actually involve both this property together. One is the homogeneity property, another is your additivity property, only when we call them linear. So your analytical solutions are available, analytical solutions are available for linear type electrical circuit or system. But in most of the cases, your circuit or system will not be linear. We approximate them as linear, but they are not linear. But in many other cases, even we cannot approximate viably. For this reason, numerical method will be the only technique by which otherwise you have no other alternative to handle this thing. So let me start with the course slide, and we'll be talking about it a bit. So this, and we are preparing it because in the last semester probably you have it, but this time again something has been changed. We need to accommodate it. It will take a week or so to prepare. When this will be prepared, I will supply them to you. Another issue is that the content of this course is taken or prepared from a book, textbook, Numerical Methods for Engineers by Chopra. You can have this book if you have access to a library. You can have this thing. I have a soft copy of this book, although it is not ethical to use, but I have no other way to have this thing. For this reason, we will be using this thing. I will supply it to a Google Drive. I will share it, the link to your WhatsApp group, and you need your IUT email to access it. So these are the mathematical technique. Probably in the section A, when I was interacting with them, they said that some of the methods already mentioned they are here are with them in power system course. For example, Newton-Raphson method or Gauss-Seidel method, something like this. Have you learned this there in power system?
Yes, sir.
Okay, then you have some idea about this. Actually, these are the numerical method by which you have solved some engineering problem actually, isn't it? Rather than using analytical technique. The thing is that whatever method mentioned here in this syllabus are simply solving the standard problem of mathematics like integration, like differentiation, like differential equations or system of algebraic equation, both linear or nonlinear, finding the roots of linear and nonlinear equations, something like this. All the methods will be there based on the mathematical technique that we usually encounter in our engineering problem. Another issue is that for solving a particular problem, type of problem, we may need different types of method. The reason is that as you have already, I have already mentioned that numerical technique is an approximated technique. That approximation will always incur some error. If your error is there and if that error is subsequently propagated in the subsequent step of calculation, then that accumulated error will simply make your solution unusable. Number one. Second thing is your error may arise from the computational machines that you are using, and those computational machine will have some certain capability. You cannot go beyond this, and that will also cause some problem in your numerical answer. Okay, at this point, I am asking you to explore the internet to find some examples of numerical disaster. That means some historical disaster happened due to numerical, not numerical error, but computational incapability of your computer. Okay, like Patriot missile or, for example, Discovery space shuttle or something like this. Try to learn about it by yourself. That what are the causes of those accidents and how those things was attributed. So this method we will be going gradually on it. And before going to that, we will be discussing few general methods of system modeling, then gradually go to the specific problem and try to learn the underlying numerical method that we usually use to solve them. Okay, and the definition of numerical method I have already given to you. Actually, the analytical equations that we usually derive from a mathematical model can be solved by using simple arithmetic operations by using computer or even by using a hand calculator. Okay, you see your mathematical modeling actually cannot be done by anybody. If you want to mathematically model an engineering problem that I have shown in the other slide, what you need to do, you have to understand the mechanism of operation of that particular system. Once you know the operation of the system, that what you need to know, you have to know some natural laws that will be applicable to that system just to derive the relationship among physical quantities. Like in our case, we use Kirchhoff's current law, Kirchhoff's voltage law, something like this. These sorts of laws are actually somewhere or other related to energy conservation principle. All these things will be available to us. Then we will be obtaining our system equations that we call mathematical model of our engineering system. And this is described in this flow chart. And the system as a whole can be represented by a very, very general form, something like this. We will have, we will have for example, why annotation is not appearing easily. Okay, we will have the equation, general equation of this form. And you see that we are calling something independent variable. Okay. And you see that in the last slide or in last few whiteboard, we considered that a system is there and an input is given, we are getting an output. In mathematical sense, if the relationship is something like that, y is equal to some function of x, is it not a functional relationship between y and x? And that
Yes, sir.
y we call it independent variable, dependent variable, and x is the independent variable, isn't it? This is what the simplest form of representation of input output of a system. So in a complicated system, this relationship will be complicated. Even it will contain multiple output, even multiple input. Accordingly, we have to derive the system. So generally, the system will have the general form. It will have an independent variable or a number of independent variables that signify the output of your system. And that output will depend on the input that we call independent variables. And there may be some parameters there, those parameters, and some input. Input is sometimes called forcing function. So our objective is first what? If we have a system given, that from that system, we have to develop that relationship, the mathematical model. Once that mathematical models are available to us, then we will seek for the solution numerically in this case, okay, not analytically. Okay, I will be finishing my lecture, today's lecture using this thing. The reason is that, okay, although because we are following this book, for this reason the mechanical example came first, but I will be giving some electrical example later in the next day, inshallah. You see that if we have, don't you know this relationship F equal to ma?
Yes, sir. Yes, sir.
Did not you Newton's second law? Now tell me, is this law is actually correct? Can is this can be practically implementable? When have you encountered this law first? Probably in very elementary level, isn't it? At that time, I hope that your teacher might have expressed the thing to you that this law is actually in practice an impossible event. This says that if we have F equal to ma, that means when a force is applied to a mass that is very ideal, no friction is there, then what will happen? The mass will begin to move. And if we withdraw the force, what will happen?
Sir, it will go on. Yeah.
Sorry? If we withdraw the force, for example, after applying the force and we mass started to move, then we withdraw the force, then what will happen? Yes, that means it keep going on moving, isn't it? If it is keep going on moving, then it motion become perpetual. Is this possible in real life? Not possible actually. So this is a simple formulation. That formulation is not possible. If you want to make it practically possible, okay, try to think about it, what particular thing should be added with it to make it more practical, okay? And with this thing, we will be starting our lecture in the next day, inshallah. That's it from my part today.